Hello everybody, our group is going to talk about solar power. We will use some example to discuss this topic by explaining the improvement process. Now let me introduce. Solar energy is a radiation and heat from the sun, utilize a series of continuously developing technologies such as solar heating, photovoltaic solar buildings, and so on. Most importantly, solar energy is an important source of renewable energy. Next, we want to introduce a new energy power generation mode in Western China, namely Lava Tower Solar Thermal Power Station, as an example to introduce our theme. The working principle is a working mode is to use tens of thousands helistad facing the center of height absorption tower. The helistad is arranged around the height absorption tower in a concentric circle. When arranging, ensure that each helistad can reflect sunlight, and also can reflect sunlight to the high absorption tower. It generates high energy by collecting sunlight and collecting it in a high temperature oscillate storage tank, ultimately convert into electric energy.
Okay, thanks for my groupmate's wonderful speech. Now I will continue to introduce another method of converting solar energy into electricity. First part I will mention is about the basic working principle of solar cells. A solar cell is a device that converts sunlight into electricity through the photovoltaic effect. A solar cell is not a battery by definition, as it doesn't store energy and is a photoelectric component. And I will moving on to the working principle part. The basic structure of a solar cell is a combination of p-type semiconductors, which produce small free electrons, and n-type semiconductors, which produce small pairs of holes, both of them called charge carriers. Due to the diffusion caused by different effective carrier concentrations at both ends of N and P, an internal electric field pointing from N to P will be generated at the junction of two kinds of semiconductors, which will handle the diffusion effect of the carriers. This phenomenon is called p-n junction. When the p-n junction is irradiated by sunlight, the semiconductor is affected by the change of illumination and temperature, and two kinds of charge carriers will be excited respectively. Because of the electric field built in, electrons move to the n-type semiconductor and holes move to the p-type semiconductor. A potential difference is gradually created between the two semiconductors. P and N connected through a wire, and an electronic current is generated. This is the simplest introduction of traditional solar cells. Next, my team member will continue to introduce the development of solar energy.
Okay, so I will introduce the second generation solar cells that is called the GEST1012 solar cells. So before introduce this working method, I will first give you a brief comparison between the semiconductor and fuel cells. So it works like this: when the electrons receive the solar energy, and then it will shoot up and leave in the electron holes. So it is a combination due to the Coulomb force. So this combination can call the exton. So it is the intermediate state. So after receiving the solar power again, it will shoot up, and then it will become the truly free electrons. So this process is about flowing, and this flowing can generate the current. So actually, there are others electron holes on the surface. So these electron holes might attract this free electron. So it is a wasting of the solar energy. So next is about the atomic solar cells, and it is a process it is very similar to the other one. And once it receives the solar energy, it will then become the extonic. But the main difference is that it is electrons accepting. So this acceptor, it is very easily carried and attracting the electrons. So electrons might be trapped by this acceptor, and this acceptor will carry this electron flowing in the cells. So this flowing also generates a current. And we all know that there are many of the advantages of this exonic solar cells, like it is very cheap and it can easily produced. But there are other weaknesses, like it is its material, because it is unfitting, so it can reduce its life and efficiency and stability. And also it is unstable current due to it is difficult to control. And also it is short life because it can easily react with others like the oil and water and accelerate the aging of the material. And also it is energy wasting. So how to solve these problems? And that is my teammate's part will introduce about this.
And now I would like to introduce about the challenge in improvement of solar power nowadays. The first part of it is challenge of solar power, and the second part is new improvement and breakthrough. For the first challenge, I would like to introduce the first challenge is solar power efficiency. And even the recent technological advances, solar efficiency has ample room for improvement. The average solar panel is only 17 to 19% efficient. In other words, 81 to 83% of solar energy goes to waste. And the second challenge is solar power intensity. For now, solar is only viable in some certain geographic regions, which limits the industry. The average cost of solar is not worthwhile in many regions. And the third challenge is solar power reliability. There are many solutions to avoid, like tracking panels follow the sun to extend the peak energy production, or storage batteries are another possible solution. They will store some energy throughout the day for use at night. However, improvement is still necessary. And I would like to introduce an experiment done by Professor Xing from University of Macau and his fellows called long-range balanced electron and hole transport length in inorganic, and it actually transcending the traditional construct of solution process semiconductor, and it improves the solar cell material combined with a good optical absorption with efficient charge transport properties, which are two main conditions for an ideal solar cell material.
Okay, let me continue to talk about the advantages. About solar energy, it has the largest natural energy reserve among various natural energy sources. Solar energy has the largest reserve, higher than the sum of all other energy sources. And second one is about not as limited in location setting as other renewable sources such as wind or tide is also an important point. And let me turn to the disadvantages. Intermittent power requires sunny weather. It's obvious that solar panels need sunlight to generate electricity. They won't produce electricity at night. And the second one is the high initial cost of panels. But as industry expands, this drawback is slowly disappearing. Okay, let my groupmates continue.
And the last part is actually conclusion. And the conclusion is mainly about the solar energy affecting the future electricity grid formation. For the first, it's decarbonizing. It's apparently because it's a renewable energy, it will play a big part in decarbonizing. And the second is replacement, because it's become cheaper and cheaper. So solar price now beats nuclear coal and gas-fired power, and potentially can replace this traditional energy. The third part is off-grid applicants. According to a report, some 20 million households have access to electricity through solar home system. It can help more people to get access to electricity. And so that's all. Thank you for listening.